Hello, my name's Nigel Bowden. I'd like to welcome you to episode 4 of the Wi-Fi for Beginners podcast. This is a series of podcasts discussing the fundamentals of wireless LAN networking, and in each of the episodes we'll be taking a look at a different aspect of Wi-Fi networking to help build your understanding and knowledge of wireless networks. Along with each episode I'll be supplying a set of slides which you can review to look at some of the topics we discussed in a little bit more detail. You can actually view these as you're listening to the podcast, but it's not essential. You can go in and look at them a little bit later on, and as I say, just to sort of reinforce some of the material that we cover. All of the recordings and the supporting material, such as the slides, can be found at my website, which is wififorbeginners.com. So if you go along to wififorbeginners.com, that's all one word, then you'll be able to find all of the slides, audio recordings, and there's a few quizzes, and there'll be a few references as well to a few other useful learning resources. Just very quickly, I've already covered this in episode 1, so I'm just going to fly through it in this particular episode. Just to let you know what we're hoping to achieve with this podcast series. I'm trying to deliver a series of audio presentations in hopefully a very easy to understand format that you can have a listen to maybe on your daily commute or while you're doing your jogging or exercising at the gym. It's pretty much aimed at people who already have a level of networking knowledge and experience. Typically be maybe network IT professionals, maybe a few students, people like that who already got a little bit of a background on networking. I have to assume a certain level of knowledge. I can't teach all of the fundamentals of networking, unfortunately, so hopefully you're fairly familiar with a few things like the OSI 7-layer model, know a little bit about Ethernet switching and routing, IP addressing, local area networks, and importantly as well, I think it's definitely worth going back and reviewing some of the previous episodes if you're rather than diving in on this one, which is episode 4. Maybe have a listen to the first 3 episodes where we did a little bit of a review of the high-level concepts of Wi-Fi networking and the type of Wi-Fi networking that we're talking about here. The wireless LANs we're discussing, they are very much in the commercial, professional environment rather than being the home networking scenario. Okay, very quickly, again, a little bit about myself. My name is Nigel Bowden. I'm based in the UK. Been working in the IT industry for over 30 years, doing various different roles, various different types of networking. Been specialising in wireless LANs for the past 5 years. I've got a few industry certifications, including the CWNP, CWNE certification. I'm number 135, and I've also got some Cisco certifications around routing and switching and wireless as well. My day-to-day role tends to be doing design consultancy and deployments of wireless LAN networks, mainly around Cisco, and I'm pretty active as well on social media, so you can find me on Twitter. My handle on Twitter is Wi-Fi Nigel, all one word, and you can also find me on the web at wifinigel.com. That's my blog site. Okay, so as I've explained previously, I've broken this series down into a number of modules, and each module will comprise a number of episodes. In the first module we took a look at high-level concepts of Wi-Fi networking, and in this particular module, which is probably going to run over 2 or 3 episodes, we're going to take a bit more of a deep dive into exactly what we mean by RF, that's radio frequency, and various RF concepts, because it's a very key topic obviously with us discussing wireless networks. Have an appreciation of what we mean by RF and how it works is pretty fundamental, and I think it's probably one of the most challenging areas for people who are perhaps new to Wi-Fi networks, fairly comfortable with wired networks and the concepts around that, but wireless and RF theory and technologies is a little bit of a new area for many people. So just very briefly, in this particular module we're going to be taking a look at what do we actually mean by RF. RF, by the way, stands for radio frequency. You probably already knew that, but it's worth just spelling it out. Have a little bit of a look at what we mean by electromagnetic signals. We'll talk a little bit about the RF spectrum, the radio frequency spectrum. We'll look at a few important RF concepts. We'll be looking at coverage areas, propagation of RF signals, modulation of RF signals. We'll also be taking a little bit of a look at RF behavior, the way that RF signals behave in various scenarios, and we'll also start to apply this more to Wi-Fi networking, so it's got a little bit of a better context. We'll start talking about the Wi-Fi bands and the frequencies that we use for wireless LAN networking. So if you are following along with the slides, by the way, I'm actually up to slide number 6 now. We're actually going to dive into the topic in a little bit of depth now. So what do we actually mean by RF? As I've already said, RF is an abbreviation for radio frequency, and it's a very common term that you'll hear bandied about when discussing wireless LANs. And what it actually refers to is electrical signals that are propagated through space. So in strictest terms, it's electromagnetic signals which are propagated through space. And when we say they're propagated through space, it means between 2 points. It could be through the air. It doesn't necessarily mean outer space. It's just point A and point B. There are signals passing between the 2 points without any obstructions in the way particularly. And radio frequency signals are used to enable a whole range of communication systems. Many of them you'll have heard before. We've got things like commercial radio systems, which is your FM stations, your AM stations. We've got satellite communications, which you're probably fairly familiar with from TV broadcasts. We've got things like the emergency services, radio communication systems. We've got cellular phone systems, which give us all of our mobile cellular communications. We've got our terrestrial TV system, which obviously beams all of our TV programs to us. We've obviously got Wi-Fi networking, which is the subject of this particular series. So we've got wireless LANs which are enabled by RF, and we've got things like Bluetooth devices such as headsets. You've got Bluetooth mice, keyboards. That they're all using radio frequency signals to enable us to provide some sort of service, provide some sort of communications. And a little bit more of a refinement of what we actually mean by a radio frequency signal. We've already talked about the fact that we're transferring electrical signals through the air, electromagnetic waves travelling through the air, but a radio frequency signal in its strictest term is a high frequency alternating current. We'll do a little bit of more of a deep dive around this. An alternating current, you may have heard of this concept in the past. Maybe you did physics at school, science at school, and you've talked about the differences between direct currents, alternating currents, and did various experiments with small batteries and lamps and bells and buzzers and operated them and sort of explored the basis of electricity. So we are really going down to the sort of grassroots here of how we get to RF signals. But I think it's important to understand, where this actually comes from. So if we take it right back to the most basic type of electrical current that we can think about. Again, think back to school days. We're connecting up maybe a small lamp to a small cell, a battery, and when we connect the battery to the cell, because of a direct current flowing from the positive to the negative terminals of the battery, the lamp lights up. I'm sure you've all seen this, and it's a very common scenario that hopefully most people have experienced. And what's actually going on here is that a current is flowing from one terminal of the battery through the carbon filament of the lamp itself, and because the resistance of the lamp, it heats up, generates light because of the energy produced, and then the current carries on flowing through to the other terminal of the battery. And by convention we say that the current flows in the direction from the positive terminal to the negative. So all of the electrons are flowing through the wire, through the battery, flowing in one direction. It's a direct current. It's literally going in one direction the whole time, causing the lamp to light. Okay, so one of the problems with direct current transmission of energy in this particular way is that it doesn't really work over a long distance too well. And we're still talking about energy flowing through wires here. If you think of the electrical system to your house, if you were trying to supply energy using direct current, because the resistance of cables, things like this, direct current just does not travel over long distances. By the time it reaches your house, the voltage will be so low it just wouldn't be of any use. And so an alternative method of generating electricity was discovered, which is an alternating current technique. Alternating current actually means that the current, instead of flowing in one direction all of the time, it'll flow for a short time in one direction. The voltage will build up, flowing in one direction, and then over time it actually reduces and then starts to flow in the opposite direction. So you can think of an alternating current, flows in one direction for a short period of time, then flows in the other direction, and you've got this cycling of the current going back and forth. If you look at the slides there, look at slide 8, you can actually see a representation of what's called an alternating current sine wave, and you actually see the value of the voltage rising in one direction, then it falls off and then flows in the opposite direction. And a sort of conceptual way of thinking about this is to think of our simple example where we've got a small battery supplying a lamp, and if you imagine the battery flipping back and forth, so that the positive and negative terminals changing back and forth so that current flows in one direction then the other, you start to visualize what an alternating current might actually look like. And the good thing about alternating currents like this is that they can actually be transmitted through cables over much longer distances. You can use transformers and various other components to step voltages up and down. It's a much more useful form of energy that you can transfer over longer distances. And examples of things that might generate alternating current is in the slides on slide 8 there I've got an example of a very old-fashioned dynamo. Now if you're my sort of age, you might be able to think back to the old days where you would have a dynamo which was attached to the wheel of a bicycle, and as the wheel went round the dynamo turned, and we have a small coil going round and round in a magnetic field, and it would generate enough electricity to actually light a lamp on the front of a bike as you rode along. So you're probably starting to wonder, what has any of this got to do with Wi-Fi networking or wireless signals in general? But these are very important concepts. This whole notion of an alternating current, an alternating voltage is key to RF theory. And just to sort of recap it again, an alternating current, you'll often see the abbreviation AC for an alternating current and DC for a direct current. So if we've got an alternating current, it's usually generated by a dynamo or maybe a generator at a power station, and the current direction is regularly changing back and forth, positive and negative, as the coils of a generator rotate in a magnetic field. And we've got this concept of a cycle. As the current changes from one direction, flows in the other direction, and then back again, that gives us one cycle of the alternating current. And by rotating the coil of the generator at a higher speed, we actually cause the polarity shifts back and forth, the cycles, to actually increase, and this increase in cycles gives an increase into what's called the frequency of the alternating current. So the number of cycles which we have going back and forth per second is known as the frequency of the alternating current, and by speeding the generator up we get a higher frequency, and by lowering the speed of it we get a lower frequency as the back and forth cycles increase and decrease. So if you're following along on the slides, you might want to go along to slide 10, where I've actually given a little bit of a representation of what we've been talking about here. I know we've been labouring this for quite a long time, but alternating current theory is pretty key to this, and what we're showing on slide 10 is our simple example of a lamp connected up to a power source again, but this time, instead of being connected to a DC source, a direct current battery, we've actually connected it to an AC source, which could be a generator or a dynamo, and we've got some arrows there indicating that for one half of the cycle the current flows in one direction, then for the second half of the cycle it flows in the other. And you may sort of wonder Okay, if the current's changing in one direction then the other, why do we not see the lamp flashing? That was always one thing that always puzzled me when I was younger, because the current's sort of going in one direction then the other. You would expect that maybe you'd see some flashing as the voltages and currents died up and down, but it's purely due to the fact that the rate that the current's going backwards and forwards changing polarity so fast that your eye just can't detect it. If you could slow it down enough, below about I don't know, about 10-20 hertz, something like that, you probably see it fairly comfortably with this thing sort of flashing away. So again, returning to some important pieces of theory now, which is going to start leading into RF theory. We've got this basic unit of measurement of a cycle of current change. We talk about the fact that if we have one cycle of current change each second, this is known as a frequency of 1 hertz. Okay, so and we can step this up in multiples. So if we get 10 cycles back and forth in 1 second, this is known as 10 hertz. And this just keeps multiplying up. So one frequency you may be familiar with is your home AC main supply. In the UK, the current goes back and forth 50 times per second, and we have a 50 hertz AC main supply. I think in other countries there may be 60 hertz, which means that the current is going back and forth 60 times in a second. So that gives us our basic unit of frequency measurement, which, as well as applying in cables, also applies when we start talking about radio frequency signals and Wi-Fi networks. So just return to our original example of a basic electrical circuit where we've got a battery connected to some device such as a lamp, and we've got a direct current flowing in one direction from positive to negative terminals of the battery. When we have this current flowing, we also have an electric and a magnetic field which are created, which surround the wire as the current flows. And in the case of a direct current circuit where we've just got a battery with current flowing in one direction, these are stable fields which just sit there, and as I say, they're stable, they go in one direction and they remain constant. If you now imagine, instead of applying a direct current to that circuit, you apply an alternating current to that circuit, you can perhaps imagine that the electric field and the magnetic field, instead of sitting there as constant entities as they do with the direct current, because the electrical current of an AC circuit is changing direction and it's rising and decaying over time constantly. As the current flows back and forth, then the electric field and the magnetic fields which exist around the wire, they are constantly collapsing and being built up each time that the current flows back and forth. And an interesting thing happens when we reach a particular frequency. If we have our AC signal flowing through the wire, it's going back and forth, the electric and the magnetic fields are collapsing and being recreated, collapsing, recreated, time and time again. If we get our current to go back and forth at a high enough rate, at a high enough frequency, eventually the electric and magnetic fields, which are combined into what's called an electromagnetic field, the electromagnetic field itself, because of the high frequency of the current and the field that's set up, if it gets to a high enough frequency, it will actually break free of the conductor and travel through the air and will actually be conducted through space, through free space, as electromagnetic waves. So we need to get the frequency up to the order of several thousand cycles per second, so several thousand hertz. The AC signal's got to be going backs and forwards thousands of times per second, but the electromagnetic field which is created around the wire is of sufficient frequency where it can actually be propagated, it can travel through space. And now we've actually moved from the realms of wired electrical circuits, and we're actually now talking about wireless signals. We have these electromagnetic signals travelling through space, and we are well and truly into the realms of wireless networking, where we're actually able to make an electromagnetic signal travel from a wire to a receiver over a particular distance. And Just one other element we haven't actually talked about up to now. We've talked about AC signals, alternating currents being generated by a dynamo or maybe a generator, but when we start talking about RF circuits, then what we're actually talking about is a device such as an electronic circuit, which is called an oscillator, which is actually going to give us the same effect as a generator, but we obviously can't have mechanical generators being used to generate signals, so we have oscillator circuits which are created through a variety of components to give us this alternating current, which is at high enough levels for it to actually leave a wire and travel through space and give us our wireless signals. So that gives us a pretty good idea of how we actually go from the basic electric signal and actually build it up to become an electromagnetic wave, which we can have transferring through the air between transmitter and receiver, and it gives us sort of our whole wireless RF technology in theory. And this forms the basis of RF communications, this ability to make electromagnetic waves leave a conductor, travel through the air, and typically we'll have a transmitting station which will transmit an electromagnetic wave and a receiving station which will receive that electromagnetic wave. So we've covered quite a bit of fairly basic electrical circuit theory there, and a little bit about how we actually generate AC currents and how that transforms into electromagnetic waves to give us the basic building blocks of wireless technology, wireless techniques. So we've probably done enough for this particular episode. We've covered a fair amount of fairly dry material there, and hopefully this will be one of those episodes where you'll find quite a bit of value actually going and taking a look at the slides, maybe recapping some of this information, just to try and get the fundamental building blocks of how we arrive at RF signals. So I think that's probably enough RF theory for one episode. We'll build further on these concepts in the next episode, where we'll continue in this module around RF theory. Just wanted to remind you that it's worth paying a visit to the website. It's wififorbeginners.com. You can find the slides that accompany this particular module and all the previous episodes, and also I've got some quizzes up there and other sources of information that you might find useful in your quest to learn more about Wi-Fi networking. So thank you very much for joining me. I shall join you again soon for another episode where we'll explore a little bit more deeply into the world of RF theory. Hopefully it's not too dry a topic. It's certainly a very important one when talking about wireless LAN networking. It's certainly one it's worth investing some of your time to really get to grips with and understand in a reasonable amount of detail. Anyway, thanks for joining me. I look forward to joining you again soon, and take care.